So this video is on how to do problems on the Unit 3 D-Day review. And you want to make sure you know how to do these for our test, which is going to be on block day, Wednesday. And so my goal is for you guys to use this not to do the assignment, but to check your answers or to see how to do ones that you don't understand. Okay, so let's get started here. So on this first problem, it says, given the image below, describe the transformations. And on this, when they copied this image really should be right here, here, all the way to here. It did not change size, okay? So it just kind of looks like it got cut a little bit when they copied it. So we want to see how triangle ABC got moved to now be at triangle A prime, C prime, B prime. So it looks like we've done a couple things. So it looks like this went up 2 and right 2 to get to here. So we translated up 2, right 2. Then it looks like we did a reflection. So I just drew in the translation. Okay, so we said we had translated it up to, right to. And you can see that would give us this purple triangle here. Then we want to reflect it. And to reflect it, what we're going to do is we are going to reflect it across a particular line. This is a line we're going to reflect it across, and that line is a vertical line, and that's going to be x equal 1. So we are going to reflect across line x equal 1. Okay, and then when we do that, it's going to end up right here for our answer. So again, translate up to, right to, and then reflect across the line x equal 1. On number 2, what they're asking us to do is they're asking us to figure out what size area model. They're not asking us to physically draw it or do the math. They just want to know what size would we have. And so this one here would be a 2 by 2 because we have 2 terms in each of the parentheses. Letter B would be a 1 by 2. Letter C would be a 3 by 2. And letter D would be a 3 by 3. And again, what I'm doing is counting each of the factors. So on letter D, for example, I mean, not factors, but terms. 1, 2, 3, things separated by pluses here. And on the next one, 1, 2, 3. So that's why it's a 3 by 3. And let's look at the next ones. So on number 3, we actually are going to do the work. And this is going to be a 2 by 2. We're going to have an x plus 3 and an x plus 5. And then we're going to be multiplying this out. And the top row is going to be x times both the x and the 3. So I'm going to get an x squared plus a 3x. Then the bottom row, I'm going to be multiplying the 5 with the x plus 3, and I get a 5x and a 15. And you do not leave your answer like that. You need to give me the sum of everything on the inside and combine like terms. So this would be x squared plus 8x plus 15. And that is your answer. This is actually area as a sum. The original problem that they gave us, x plus 3, x plus 5, that's area as a product. But they just wanted us to give the multiplied answer, which is adding up everything on the inside. Okay, on the next one, this time, this is two ways you can do it. You can actually just distribute, or you can do it as a 1 by 2. So you're going to have your 3x and your x minus 4. And then the 3x is going to multiply with the x and the negative 4. And I get a 3x squared minus 12x. And again, 3x times x, we could distribute 3x times negative 4. And so my final answer is going to be 3x squared minus 12x. On number 5, it says select all possible answers that are equivalent. So on this, again, if I was to multiply this out, I have a 2 by 2. And it doesn't matter what goes where. Just make sure you put the negative right in front of the 5 so you know it is negative and you don't lose that sign. So this is going to be a 2x squared, an x, a negative 10x, and a negative 5. Again, that x is multiplying with the 2x and the 1, and then for the bottom row, the negative 5 is multiplying with the 2x and the 1. So this is a 2x squared minus 9x minus 5. That would be the final cleaned up answer, which letter C is that. But you also want to kind of pay attention to this letter B, because you have a 2x squared, you have a negative 10x, you have an x, and you have a negative 5. So this is actually it before you clean it up. Now, you want it like the one I circled in red, all cleaned up. Okay, but this one is also equivalent. The ones that are not, A is not, D is not. On number 6, this is a fraction busting situation. We want to multiply by basically the least common denominator, which would be a 12 in this case, because 3 and 4 can both go into 12. So I'm going to multiply everything by 12. Let me just kind of set this up. Okay, so we had x over 3 times 12 minus, and then we had our 12 times our 3/4 equals, and then we had our 12 times our 5. Now, when we do multiply by the 12, it is really over 1. Let me put it in a different color. It is really over 1, over 1, over 1. That is really what happens when I take a fraction times a whole number. But the whole reason we were doing this is we wanted to have things cancel out, and we do. 3 goes into 12 4 times, so we end up with a 4x. And then we have 4 goes into 12 3 times, and then negative 3 times 3 is a negative 9. And then we have 12 times 5, which is 60. And now we're going to solve this. I'm going to add 9 to both sides. So I get 4x is equal to 69. I divide both sides by 4, and I get 69 over 4. And you can just leave that as an answer, or you can put in your calculator and give me a decimal. Again, if it's a multiple choice situation, you just need to see which way they write it, or which way they ask for it on the computer. On number 7, a couple of things you could do. You could distribute the 100. I am going to, or you could just divide by the 100. Okay, so if I divide this side by 100 and this side by 100, I get x minus 4 equals 2. Another way to have thought about this is doing the looking inside, where you're like, okay, I know that 100 times something gets me 200. And so I know this has to be a 2. So I know x minus 4 has to equal 2. And you see, I got the same thing that I just did when I divided by 100. I could also have distributed the 100. Now this is just going to give me bigger numbers to deal with. And then I would have had 100x minus 400 is equal to 200. And I would solve either of these equations. Okay, now the first one I had, I would add my 4 and I get x equals 6. This one here, I am going to get the same answer, but again, it's going to be a little messier. I'm going to add 400 to both sides, which gives me 600. I'm going to divide both sides by 100 and I get 6. But you see, you get the same answer. Whether I do the looking inside, whether I do the undoing by dividing both sides by 100, or if I distribute. On this problem, I am going to fraction bust is probably what I'm going to do for this. So there's a couple different ways you can do it. Let's say we fraction bust. And again, I want to multiply by the LCD, which in this case is 2, because that's the only denominator I have. So I'm going to go 2 times x over 2 minus 2 times 3 over 2 equals my 5 times 2. Over on the left side, I'm going to cancel that out. I get x. Cancel that out. I get 3 is equal to 10. I add 3 to both sides, and I get x equal 13. On number 9, this is another fraction busting. For this one, I am going to, for my LCD, I'm going to multiply by 12. Okay, let's make that a little better. So my LCD is going to be 12. I'm going to multiply everything by 12. So let me do that. I'm going to go 12 times this. I'm going to times this by 12 here. Let me not put my parenthesis. I'm going to multiply this by 12, and I'm going to multiply this by 12. Now, when I do that, 3 goes into 12 4 times, and 4 times my 2x is 8x. 4 goes into 12 3 times, and 3 times 1 is 3. And 3 goes into 12 4 times, and 4 times 2 is 8. I'm going to minus 3 from both sides. I'm going to divide both sides by 8, and I get 5/8 as my answer. Now, number 10 is a same idea. It's fraction busting, but now I have an x and a 2. So in this case, I'm actually going to be multiplying by 2x. The x is going to get rid of the x, and the 2 is going to get rid of the 2. So I'm going to multiply 2x times this, 2x times this, and 2x times this. When I do that, this x and this x cancel, and I'm going to get a 2 times 1, which is 2. Here, and let me just kind of, it's going to move the whole thing. Let's see. No, I was hoping it was just going to move that one piece. Let me just write this a little neater. Oops, I'm scribbling. Or here, let me just write it out. That way you can kind of see my math a little better. Okay, so I'm going to be multiplying everything by 2x. 2x times 1 over x, 2x times 3, and 2x times 5 over 2. So this x and this x cancel out, and I end up with 2. Here I end up with a 6x, 2 and 2, so I'm left with x and 5, which is a 5x. I am going to subtract 6x from both sides, and I get 2 is equal to negative x. And if it's a negative x, just make both sides opposite, and I get negative 2 is equal to x. And that's my equation, my solution. Now, number 11 and number 12 are dealing with what we had our quiz on, which was parallel and perpendicular lines. Now, what's true about parallel lines? They are same slope. So I know that my new equation has to have the same slope, which is 3. okay? So I know my equation is going to be y equal 3x plus b, again, because the slope has to be the same. Now, I need to put in this point, which is 3, 1 in for my x and my y. The 3 is my x, the 1 is my y. So I'm going to go 1 equal 3 times 3 plus b. Again, I'm putting the 3 right here for my x and the 1 right here for my y. So I get 1 is equal to 9 plus b. When I subtract 9 from both sides, I get negative 8 is equal to b. So my equation is y equal 3x minus 8. Okay, so the slope is the same, but my y-intercept became different. And again, you need to plug in the point that they give for your x and your y. Now, perpendicular, they are not the same slope. They are negative reciprocals. So what that means is you're going to flip and change the sign. So flip and change the sign. So in this case, my slope is this negative 2 over 3. So my perpendicular slope is going to be a positive 3 over 2, x plus b. Now I need to find my y-intercept. I have this point 0, 5. Now this happens to be a y-intercept. So anytime you have 0, a number, it is going to be a y-intercept, okay? So really that 5 is going to go right here, not over here. This 1 does not do that. That's different. That's not a y-intercept. That's 3, 1. It's not on the y-axis. So if you recognize that, you don't have to do the math. You are just going to stick the 5 here. Now, if you don't recognize that, then you're going to do what I did in the last problem. So let me just get rid of this. So what I did in the last problem, okay, in case you aren't paying attention, you're just doing the math and you didn't notice that, what's going to be happening is I would then put 5 in for my y, 0 in for my x. So again, I'm using x and y, and plus b. Now 3/2 times 0 is 0, so I get 5 is equal to b, and you see that's what I got here. So if you see you have 0, some number, that is always your y-intercept. Okay, on number 13, they want us to plot the points and make some lines. So I'm going to do this one in blue. So I'm going to go to 2, 1. Let me just kind of zoom in a little. 2, 1. I'm going to get a little fatter pen. So I just put a point. 2, 1, and 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Then I'm going to connect it. Now I'm going to make this line not as thick, and I'm going to kind of make it a little lighter. And then I'm going to draw the line. If I wanted to continue doing points, I could. So that's my line 1. Let's say I do the other one in red. So let me just get this set up. Okay, so I'm going to do this one in red. So I'm going to go to 2, 2, and then 0, 5. 1, 2, 3, 4, 5. And then I'm going to connect these points. And so I'm going to go like this. Now, these points are intersecting. They are definitely not parallel. Now, just because they intersect does not mean that they're perpendicular. They have to intersect at 90 degrees at a right angle. So what you want to do is don't eyeball it. What you're going to do is actually check the slopes. So the slope for this problem, make that a little darker. So the slope for the first equation, I could work it out using the points, or I can just count. So I'm just going to do it in green real quick, and then I'm going to take it off. From this point to this point, I'm going up 1, 2, 3, 4 over 2. So I went up 1, 2, 3, 4 over 2. So this is going to be 4 over 2, or 2. It is an increasing line. Okay. Now I'm going to do the same for the other one. So here I have a point. Oops, I think I got rid of my 1 point at 2, 2. So let me just get that point at 2, 2. I did have a point here at 2, 2. So now when I'm doing this, I'm going down 1, 2, 3 over 2. So that means that this slope is down 3 to the right 2. Now, if these were the same slope, then that would be parallel. If these were negative reciprocals, then these would be perpendicular, but it's not. The negative reciprocal of 2 would have been a negative 1/2. The negative reciprocal of 3/2 would have been a positive 2/3. We did not get these. So not parallel, because they're not the same. They are not perpendicular because they are not negative reciprocals. And again, the numbers I'm looking at are 2 and negative 3/2. Since 2 and negative 3/2 are not negative reciprocals. Okay, they are intersecting, but again, just because they're intersecting does not mean they happen to be perpendicular. They have to be perpendicular by meeting at 90 degrees. Okay, so on number 14, it says sketch. I actually, let's see, I think I added some graph paper at the end. So I'm going to be doing y equal 2/3 x minus 1. So let me just come down to the graph paper. So this is going to be y equal 2/3 x minus 1, which was problem number 14. Okay, so problem number 14. Oops, I'm doing highlighter, sorry. 14. Okay, so if I'm going to graph this, my y-intercept is this minus 1. So that means I'm going to be starting down here at 0, -1. My slope is 2/3, and what 2/3 mean I do is this is going to be up 2, right 3. Okay, if it's positive, you go up, whatever the top number is. If it's negative, you go down, whatever the top number is. And then always go to the right for the bottom number unless you're off your graph. So I am going to go up 1, 2, over 1, 2, 3. So I'm right here. Again, just visually, I went up 2, right 3. That's what I did. And then I can connect the points. Oops, I'll get a color. And there's our line. Okay, it has a positive slope, so it should be an increasing line. On the next one, what I am going to do is I'm going to do a couple of things. I am going to clean this side up. So I am going to end up getting on that side a 6 plus 3x. Now at this point I can do one of two things. I can distribute the 3, or I could actually divide everything by 3. So let's say I divide everything by 3. I can divide this by 3, this by 3, this by 3. You're allowed to do that as long as you can do it to everything. And I get x plus 2 is equal to 2 plus x. Now, when you have the same on both sides, exactly the same, this means that everything's a solution, all real numbers. Now, again, if you didn't notice that right away and you're just kind of going through the motions and doing the math and going, okay, I'm going to minus x, I'm going to minus x, and you get 2 equal 2, your answer is not x equal 2. Your answer is not 2 equal 2. Your answer is all real numbers. Everything's a solution. On number 16, okay, simplify. When they say simplify, they mean we want to get like x to a single power, y to a single power. We don't want negative exponents. In this case, we didn't have any negatives here to start with. Let me just do this. I have a 5x squared y to the third. The bottom, both my x and my y are being raised to the third power. So what you'll notice is I have y to the third on top and I have y to the third on bottom, so that can cancel out. Also, if you're looking here, I have 2 x's on top and 3 x's on bottom. That means I can cancel 2 from top and 2 from bottom. And when I cancel 2 from top, I'm left with a 5 up there. And when I cancel 2 from the bottom, I'm left with 1x. And that's my answer, 5 over x. So again, use this as a guide to check yourself and to answer questions that you didn't understand. Again, this was not meant to just, for you guys just to copy, because I want you guys to learn from it. Okay, remember, test on block day.